Hi, and welcome back to another Mr. Talbot Maths video. And in the video today, I'm going to be going through and explaining how to do the problem on the screen in front of you. So it's a little bit trickier than it seems at first glance, but if you know about factorials, you might think it's quite straightforward. It's actually a little bit trickier because of the way that we're going to solve this equation towards the end. Now, I'll get stuck into it, we'll get started, and I'll explain first of all what this exclamation point means mathematically. So if we had something like 5 factorial, that means you do 5 times 4 times 3 times 2 times 1. You multiply it by every number, every integer below, down to 0, but not including 0. Now, that would give you 5 times 4 is 20, times 3 is 60, times 2 is 120. Okay, so that would be 5 factorial. Now, what I'm going to do with these brackets, I'm going to expand it out. I'm going to write out what I would multiply x plus 2 by and get rid of that exclamation mark. So, I'd have x plus 2 multiplied by x plus 1, because remember, each time you're taking 1 away from the number. So x plus 2 take away 1 is x plus 1. Take away 1 again, we get x. Multiply that by x minus 1. By x minus 2, and you keep going all the way down until you get to 2 multiplied by 1. And that's all divided by x minus 1, take 1 away from it, multiplied by x minus 2, all the way down until we get to 2 times by 1. Now, that's still equal to 24, and hopefully at this point what you've noticed is the 1 on the top will cancel out with the 1 on the bottom, so will the 2, so will all the numbers in between and up to x minus 2, x minus 2 will cancel, x minus 1 will cancel, and so we get left with x plus 2 times by x plus 1 times by x is 24. Okay, now we need to then start expanding these double brackets, and then we're going to multiply everything after that by x, and will still be equal to 24. So we're going to get x times x, which is x squared. We're then going to get 2 times x, which is 2x, 1 times x, which is x. So that's going to give us plus 3x. 2 times 1 is 2. And now we've got to multiply everything by x. Okay, x times x squared is x cubed, plus 3x squared plus 2x is equal to 24. What we now need to do is take away 24 from both sides. So we've got a quadratic, sorry, not a quadratic, a cubic, which is equal to 0. So I'm going to get x cubed plus 3x squared plus 2x minus 24, and that is equal to 0. Okay, now the next part is definitely A-level maths, but it also comes in further maths, and it's a theorem called the factor theorem. So basically, if I say let's find x, let's plug x in as something. Let's say x is equal to, I don't know, a. X is equal to some number a. Now if x is equal to a and that works in here, that gives us an answer equal to 0, and that means that x minus a is a factor. Now I'll show you exactly what this means in practice now. So I'm just going to try any number for x. Okay, I'm assuming that there will be a whole number solution for x. So I can try 0, so 0 cubed, plus 3 lots of 0 squared, plus 2 lots of 0, that'll all be 0, minus 24 won't give me an answer of 0. And then I could try something else. I could try like 1, negative 1, 2, 3, things like that. Now, I do know that if it's going to be a solution, it's also going to be a factor of minus 24. So you've got that to bear in mind as well, because if it's a solution, let's say, I don't know, 3 is a solution, so x is 3, that will give us an answer of 0. X minus 3 would be a factor, and that means obviously if I've got my brackets, I've got it factorised, 3 times something has to give me minus 24, or minus 3 times something gives me minus 24. So it's also going to be a factor of minus 24. So let's just, I'll talk through this bit rather than writing it all down, so we might run out of space, but 1 cubed is 1, plus 3 times 1 squared. So that's 1 plus 3 is 4, plus 2 lots of 1, that's 6. 6 minus 24 is not going to be 0. Let's try 2. 2 cubed is 8. 2 squared is 4. 3 times 4 is 12. I've got 8 add 12. And then 2 times by 2, 8 add 12, sorry, was 20. 2 times by 2 is 4. So I've got 20 add 4 minus 24 is 0. That does work. Okay, so 2 cubed plus 3 lots of 2 squared plus 2 lots of 2 minus 24 does equal 0. So that means that 2 is a solution to the equation if and only if x minus 2 is a factor. Now that means I can rewrite this bit, and I'm just going to actually, well, no, I'll leave it as it is, but we know x minus 2 is a factor. So going from here to here, x minus 2 times by some bracket will give me this. Now I know it's got to be x squared times x is x cubed. Now minus 2 times something is in minus 24, that's got to be plus 12. Now the next bit here I'm going to do by a method called inspection, and that's basically by working out what I would need to give me 2x, or what I would need to give me 3x squared. So, x times 12 is 12x. I'm looking at this 2x term here. Okay, I'm looking at 2x and how I can make that. Now I can make it by doing x times by 12. That gives me 12x. I would then do minus 2 times by some lot of x. So 12x, I need to get to 2x, so I need this bit when multiplied to give me minus 10x. Now minus 10 divided by minus 2 gives me a plus 5x. Now I want to just check that that also works with the 3x squared term. So to make 3x squared, to give me the squared terms, I need minus 2x squared. And I also need x times by 5x. So it gives me 5x squared minus 2x squared does give me 3x squared. Okay. So it does work for both of the middle terms, so I know that's the right factorisation. And now what I need to do is I need to work out the solutions to x squared plus 5x plus 12. And what we're going to find here is that this bit is there's a bit of an issue with. And why is there a bit of an issue with it? Well, if you do what's called the discriminant, so the discriminant is b squared minus 4ac. I was about to write the square root, you don't actually need that bit. The discriminant is what goes inside the square root in your quadratic formula. Now, think about what number can you not square root. We can't square root negative numbers. Okay, so if I write out the whole quadratic formula here, it's this all over 2a. You can't square root a negative number, so the quadratic formula will fail at that point. Now if we work out b squared minus 4ac here, well b squared is 5 squared, 25, take away 4 times 1 times 12. So you end up with 25, take away 48. That's obviously going to be a negative number, and so this won't work as well as it won't work in terms of giving us a positive or even negative numbers. It won't work. We can't square root a negative number. Well, at A level, and further maths A level, you can do that. So I'm going to write this out. So we know that x is equal to 2 is one solution. But our other solutions we can get from using this quadratic formula. So minus 5 plus or minus the square root 5 squared minus 4 times 1 times 12. All divided by 2 times 1. So that gives us that x is equal to minus 5 plus or minus square root of 25 minus 48 all divided by 2. So we'll keep going. X is equal to minus 5 plus or minus negative 23 over 2. Now, from this point, what we can do is I can split up this square root. Now, where do the imaginary numbers come in? Well, it's to do with square roots in the negative. Negative 23 is the square root of negative 1 times by the square root of 23. Now, with imaginary numbers, the problem is the negative 1. We're just going to use square root of negative 1 as a thing called I. It stands for an imaginary number, okay? Or imaginary unit. So we end up with minus 5 over 2. I'm just going to split the fraction up here as well. Plus or minus I, square root of negative 1, I've just written that now as I, over 2 root 23. Okay, so there are our two answers. You've got x is equal to negative 2, and we've got x is equal to minus 2.5 plus or minus half of I root 23. Now, that's great in terms of, we've got those solutions, but if we go back to the question, would an imaginary solution work in here? Now, because of the way that factorials are defined, it's not going to work because factorials are only used with positive whole numbers, positive integers, okay? Because obviously if we're taking away 1 down to 0, it's going to be, it's going to get a bit messy, especially if you're working, well, a bit impossible, rather, with imaginary numbers. So, yeah, factorial is only defined for positive integers. So our only actual solution that would work when we put it back into here is x is equal to 2, but we do have those other imaginary solutions if you work through the problem and find the solutions of the quadratic in there. Okay, I hope you've learned something new there in terms of that might have been factorials, that might have been imaginary numbers, that might have been factor theorem. And if you got the solution of 2 at the start, brilliant, well done. If you got the other solutions as well, which other solutions, technically not, it's a bit weird because they're imaginary numbers. It's like, do they count, do they not? I'm not really too sure myself, although they wouldn't work in the actual question. So what I would do if I was doing this in a question, I'd write them down and just say, they won't work, so probably just cross them out. Won't work in the question. Okay, yep, leave a like on the video if you enjoyed, and I will see you in the next one, next Monday at 5 PM. Bye-bye.